All right, here we go. Section 4.1. This is chapter 4. It's quite a major chapter, actually. We're in chapter 4 for 10 sections. So let's just start it one at a time here. Here's section 4.1. Graph quadratic functions in standard form. So a couple vocab pieces for you. Quadratic function is a function that can be written in standard form. And then here we are in standard form as y is equal to ax squared plus bx plus c. We also, just to let you know, heads up, we have two other forms, and the next lecture will explain the other two. But this is called standard form, and again, three different forms for quadratic function. What is a parabola? It is the U-shaped graph of a quadratic function. What is the vertex? It is either the lowest or the highest point on a parabola. The axis of symmetry is a vertical line that divides the parabola into mirror images and passes through the vertex. I always draw the axis of symmetry as a dashed line. It's a vertical line. It's an x equal to line. And then finally, minimum and maximum value. So for a quadratic function in standard form, the vertex's y coordinate is the minimum value of the function. And that's if a is positive. So it opens up. Let's draw that over here. If the parabola opens up and a is positive, we have a minimum. And if the parabola opens down, when a is negative, we have a maximum. Great. So here we go, parent function. And we've done this before, right? We did the parent function for the line. We've done a parent function for an absolute value. And now we're back to the parent function for a quadratic function. So the parent function is no big deal in the sense that it's just x squared. A is equal to 1, b is equal to 0, c is equal to 0. And here it is, beautiful U-shaped graph of the quadratic function, and it's called a parabola. We have the axis of symmetry. Let's dash that in just like I said I would. It's a nice axis symmetry. In this case, the axis symmetry would be x equal to 0. Right? And all these points are points of symmetry. You always reflect and see an opposite point. The only point, such a sad thing, but the vertex. The vertex has no symmetric point, and the vertex lies on the axis symmetry. In this case, the vertex at 0, 0. The vertex here also is a minimum. And notice also maybe the shape of this. If I move over 1 and square 1, I get 1. But check this next move out. If I move over 2 on the x, I square 2, I bounce all the way up to 4, and you can feel that acceleration. Move over 3, square 3, and wow, I'm way up at 9. Then at 16. So it's really an acceleration of this function. And for f of x equal to ax squared, for any quadratic function, g of x, where b is 0, the vertex lies on x on the y-axis. So again, it's a nice, in standard form, when b goes to 0, things get a little easier. Vertex always on the axis symmetry. And axis symmetry in this case would be x equal to 0. Let's move on. Hey, so here's an example. Let's go ahead and graph. And again, we're in standard form, but b is equal to 0, which is going to kind of simplify things for us, which is a nice place to start. So here's the example we'd like to do. We'd like to graph y is equal to negative 2x squared plus 2. So just looking at this, we've got the negative. Hopefully, just like the absolute value, that's going to cause our parabola to flip over. 2 is going to make it a bit narrower. And the plus 2 is actually going to be a vertical shift. We're going to move up 2. You can fill in a table, right? And that's always a good idea. If I plug in 0, I get 2. If I plug in 1, 1 squared is 1, right? Times 2, negative 2 is negative 2. Plus 2 would come out to 0. And then you should not have to plug this number in again. You can see these are points of symmetry. That's also 0. Right? They're the equal distance from the axis of symmetry. If I plug in 2 here, I should get negative 6. And then this guy is also negative 6. So if we plot the points, we're going to be up 2 units. Right? I think the scale here is 2, so let's be careful with that. And then at when I move over 2, I'm down negative 6. I'm here. Again, a skinny parabola. And I believe these guys are here. So nice parabola, faces down. Here we go. So it's a smooth curve. No ruler can be handed out to help you graph a parabola. And if you compare the graphs, they both have the same axis of symmetry, right? And that's actually x equal to 0. However, notice that this graph negative 2x squared plus 2 opens down, right? And is narrower. Narrow. We felt the same thing with the absolute value function when you put a number like 2 in front of the absolute value of x. Makes it narrower. And the vertex is 2 units higher. So the plus 2 in the equation shifted the parabola up 2. Okay, so let's talk about some of the properties. Again, in standard form, the graph opens up if a is greater than, come on pen, here we go. If a is greater than 0, it opens up, and we have a minimum. And if a is less than 0, it opens down. The graph is narrow if I put a number greater than 1, right? Like a 2 just in the last example. And it's wider if the number is less than 1 and greater than 0. Another way to write that is the absolute value of a is less than 1. So a half would make this parabola wider. A third, 2/3, 2/5. Lots of nice fractions. And here's a big one. Make sure you get this formula. This is the axis of symmetry is negative b over 2a. We haven't used this yet because b has been 0, but we're going to use it in a second. And then the vertex has the x-coordinate of negative b over 2a. We'll talk about that in a second. The y-intercept is always c. I don't know if you noticed that yet, but that's a huge, huge point. And from that point, we can always get a point of symmetry as well. All right, so here comes our big example, right? This is standard form graphing. We have this very nice quadratic function here, right? A is -1, B is 4, and C is -3. So let's label that in this box, 4, and C, -3. Because A is less than 1, the parabola opens down. And again, nice reality check, right? When you start plotting points and you're not getting a parabola down, then go find your mistake. Here we go, axis symmetry formula, big one, right? And I'm hoping you've seen it, but if not, this is one that has to be on your formula sheet. So in this case, we have negative, B is 4, right, over 2A is -1. And so your final answer here should say -4, right, divided by -2. The negatives will cancel, so our final answer is going to be positive. 4 divided by 2 is 2. So your axis of symmetry is 2. Let's go ahead and draw a nice dashed line in. So my vertex will lie on this point, on this line. So to find the y value of the vertex, right, I need to plug 2 into the equation. So way back up here is our equation. And so when I plug 2 in, I'm going to have negative, put parentheses, 2 squared. So the negative is not being squared, plus 4 times 2 minus 3. And that solves for 1. So there you have it. There's your vertex. Voila. A nice graph, right? They kind of showing us this parabola is opening down. Again, vertex at 1, 2. Draw the axis of symmetry. I already did that. X equal to 2 is the equation for the axis of symmetry. And then the y-intercept, super easy. Look, it's always the c value, -3. And -3 produces a point, and of course, a second point of symmetry. Notice how quickly I got that. I just moved 2 over from the axis symmetry. And for me, that's enough. I can now go ahead and throw this parabola. And again, apologize. Not getting enough curve in there. It's hard with this pen. Right there is my parabola. And this would be -3, right? They also said, look at the point of symmetry. We did that. We could even plot another point. So they said, hey, why don't we go ahead and plug 1 in, and you should get 0, right? And then its point of symmetry, it's reflective, and that's a nice word too, is 0. Excellent, well done. So again, minimum, maximum values are super important with the parabola, and I'll show you how to do these on the calculator tomorrow. Here's the minimum. We have minimums when the parabola opens up. The parabola opens up when a is greater than 0. And we have a maximum vertex when the parabola opens down, and then we get that when a is less than 0. So they say, can you find a minimum and maximum value? And so they gave us an equation. First of all, we can look straight away and see because it's negative, this parabola opens down, and we will have a maximum value for the vertex. How will we find it? First, we do the axis of symmetry, which is negative. B is 12 over 2. A is negative 3. Right away, I can see the two negatives are going to cancel. We've got 12 divided by 6, which is 2. I think that was our last axis of symmetry. I would then plug 2 into the function, right? So 3 times 2 squared plus 12 times 2 minus 6. And I'd probably put that in my calculator and get an answer of 6. So your maximum value is 6. Not 2, but 6. That's as high as this function will go. I'm running a little short on time, so I'm going to hit pause right now. I'd love it if you could try a couple problems before coming to class. And when you're ready, hit play and I'll show you the answers. And here we go. There are the answers. So nice. First one was just a reflection. A pretty simple graph. The second one, the third, wow. And so here, the third, we're going to have to talk about this more in class. How did we plot these points? You could just move over a point, or you could have moved over 3 points, right? 3 over would have squared 3 is 9. 9 times a third is 6. So the third makes this graphing, I think, pretty tricky, and we'll work on that more in class. Here's a nice parabola with the B term. Hopefully you were able to solve that. Again, look at that, another axis symmetry of 2. That doesn't always happen. And then finally, here's the minimum value. Hopefully you were able to get that as well. Okay, thanks so much. See you tomorrow in class.